Alright, let's start the class. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
So we meet again in tonight topics is topic 10. So regarding financial data analytics using multinomial logistic regression. As you all had the class before, you have the class in regarding the binary of financial data analysis using binary logistic regression. Previous class is the binary logistic regression. In tonight's class, we are going to go deeper into multinomial logistic regression. So I will also refresh your memory on the binary logistic regression, and then we continue to multinomial logistic regression. All right. So the learning objectives tonight is that you understand what is regression, what is logistic regression, what is the difference between linear and logistic, what is multinomial logistic regression, some use case, and demo. So in the regression and classification. Regarding regression and classification, in machine learning, there is what we call supervised learning, unsupervised learning, and reinforcement learning. Classification and regression is under supervised learning because there is the variable of y. If there is y, meaning that is under the supervised learning. So what is regression? Regression is a predictive modeling techniques where it will estimate the relationship between dependent variable and independent variable. The line will be like this. So, please pay attention because this is regarding your final exam. Your final exam will be regarding logistic regression. So what is logistic regression? Logistic regression produce result in binary format, which used to predict the outcome of categorical dependent variable such as 0 or 1, yes or no, true or false, high or low. Only 0 and 1 for binary format. So logistic regression produce result in binary format. So the result will be in between 0 or 1. So the question is to solve the problem of 0 or 1, why can't we use linear regression? Because linear regression can also having 1 or 0. So why we do not use linear regression? Because when we use linear regression, the line will exit the head and bottom. So let's say your Y criteria is 1 and 0, which is two category of 1 and 0. If using linear regression, it will exceed the line. So linear regression is no use for classification model 1 or 0. Linear regression only can do for continuous variable. That's why we need to have the line bending up like this. Yeah? So we need to bend the line with the maximum of 1 and minimum of 0. That's where we come up with logistic regression. Logistic regression is using what we call sigmoid curve. Yeah. So it will be maximum of 1 and minimum of 0. How to determine whether it is good or bad? So there is a threshold value. Yeah. If it is exceed the threshold value, then it is whether you put good as 1 or bad as 1. If you put good as 1, if exceed the threshold value, then it is good. If it is below threshold value, then it is bad. If you consider 0 is bad and 1 is good. But if it is upside down, if it is 0 is good, 1 is bad, meaning above the threshold will be bad, below the threshold will be good. So logistic regression is a method used to predict dependent variable given a set of independent variable such that the dependent variable is categorical, which is 1 or 0 if binary. To bend the line, we conduct the following equation. Yeah. So if using linear regression, the model will be y equal to constanta plus beta 1 plus beta 2 x2. But when we need to bend the line, we put the logistic there. Log from y divided by 1 minus y is equal to c plus b1 x1 b2 x2 and so on. So we need to bend the line here using logit. So y will be the probability of an event to happen which you are trying to predict, whether it is 1 or 0. x1 and x2 are the independent variable. Yeah, x1 and x2 are the independent variable which determine the occurrence of an event. C is the constant term, which will be the probability of the event happening when no other factors are considered. Okay. So this is the difference between linear and logistic. Linear, we use continuous variable 1, 2, 20, 30, 45, 100. That is continuous variable. Categorical 1, 2, 3, 4, 5. Yeah? Not until 1000, no. Continuous variable can be 1000. Or 1.5, 2.0, something like that. That is what we call continuous variable. Linear solve the regression problem, logistic solve the classification problem. The line in linear is straight line, and the line in the logistic is sigmoid curve. So in logistic regression, if this is the hours of studying, and this is the exam result, pass or fail. This is 0 is fail, 1 is pass. We've done the demo before. So when we conduct the logistic regression, this is the, let's say this is the output. We see it from p value whether this is significant or not. It is considered significant if it is below 0.05. So it is all significant, and this is the constanta, and this is the beta, the coefficient. So when we consider, when we have the probability is of 1 and 0, what is the probability reference is 1? Let's say the probability of reference is 1, meaning the probability of passing the exam will be 1. Yeah? Y is equal to 1 divided by 1 plus exponential with the power of minus C plus B1 X1, etc. Yeah, this is the probability of passing exam. The previous model is log y divided by 1 minus y is equal to C plus B1 X1. It goes like this. Y is equal 1 divided by 1 plus exponential by the power of constanta plus beta 1 X1, etc. So we see that probability of passing the exam in here with the model of y is equal to 1 divided by 1 plus exponential by the power of minus 4.077 plus 1.5 times hour. So when we put hour is 2, yeah, the probability of passing the exam will be 1 divided by 1 plus exponential, yeah, 1.5 times 2 minus 4.07 is 0.26. Meaning the probability of fail is 8. What is the probability of failing? If the probability of exam, the probability of passing the exam is 0.26, what is the probability of failing the exam? Anybody can answer? Yes, 0.74. Okay, so that is if the reference is passing the exam. 1 is passing the exam. Yeah? So probability of failing the exam will be 0.74. So we need to determine what is the reference. Okay, 1 is passing. What about if the hour rate is 4? So the probability of passing will be increased 0.87, and the probability of failing will be 0.13. This is the binary logistic regression. All right, let's continue with multinomial logistic regression. So multinomial logistic regression model is a model with more than one explanatory variable. So it is having more than 2 variables in the y. So minimum is 3. Y1, Y2, and Y3. Minimum. The multi-logistic regression compare multiple groups through a combination of binary logistic regression. The reference is equivalent to the highest numeric score used as the reference group. So in the multinomial logistic regression, the interpretation is slightly different with the binary logistic regression. In multinomial logistic regression, y1 is equal to exponential of constanta plus beta 1 times x variable divided by 1 plus exponential from the constanta 1 plus beta 1 times the x variable plus exponential by the power of constanta 2 plus beta 2 times x. This is using the 3 variable, yeah. So if using 3 variable, we exclude the category of the reference category. So we only use A1 and A2 instead of A3 because A3 using for the reference. Y2 is also the same, exponential of constanta 2 plus beta 2 times x divided by 1 plus exponential from constanta 1 plus beta 1x plus exponential constanta 2 plus beta 2 times x. This is the y2. And y3 is slightly different with the logistic binary. It is 1 divided by 1 plus exponential of the constanta 1 beta 1x plus exponential constanta 2 plus beta 2x as the reference category. There is no minus here, all positive. In binary, the y is equal to 1 plus exponential of minus constanta plus beta x, yeah, with minus. So in multinomial, all positive, yeah, no minus. So let's say we have an example here where we have the data of economic activity as y1, y2, and y3. And then we have gender, single, widow, married, and the age of 25 to 44, 45, 50, 50, 65, 65, 74, 75, and more. Sorry. This is the marital status. The gender is male and female. And the outcome, y1 is economically inactive, y2 is unemployed, and y3 is in employment. So let's see the result like this. So the result, y1 is unemployed. Oh, y1 is in employment, Y2 is unemployed, Y3 is economically inactive. Since Y1 is the base or the reference, the calculation will be like this. The probability of Y1 is equal to 1 divided by 1 plus exponential of minus 1.36 constanta minus 1.69 of merit minus, this is the interpretation on married men with the age of 25 and 44 ya. So 1.69 merit minus 0.001, this one, times ages of the 25 to 44 plus, this is for the Y2 ya, and this is plus exponential of minus 1.15 minus 0.11 of merit, 0.11, this one, merit minus 0.89 times the ages. So if you are married, then it is 1, and your ages is 25 to 44, it is 1. This is 1, and this is 1. That is for Y1. The probability of married men with the age of 25 for having an employment. And then for Y2, unemployed, Y2. Yeah, the interpretation will be exponential of the constanta minus 1.69 merit men minus 0.001 times ages 25, 44 divided by 1 plus exponential of minus the same like the above plus exponential of the Y3 1.15 constanta minus 0.11 times merit minus 0.89 times ages. So if you are married, it is 1, your ages is 1, this is 1, this is 1, plus this is 1, this is 1. So what is the probability of Y2? And then Y3, economically inactive. So Y3 is 1.15 constanta minus 0.11 times merit minus 0.89 times ages 25 to 44 divided by 1 plus exponential of the same. Both is the same, equal to how much? So this is to see which class is the highest probability for the married men with the ages of 25 until 44. What if, what is the master model? The master model is cater on all of this data. You input all the data, but when it is married man, it is 1. When it is 45, it is 0, 0, 0, 0. So this is 1. So for the age, when the age is 25 to 41, this is 1, meaning the other is 0, 0, 0, 0. So you put all the equation in here for the master model. Let's say Y2 is minus 1.36 minus 1.69 times merit plus, okay, let's see, let me give one example for the full model, full model. So will be exponential of minus 1.36 minus 1.69 merit plus 0.028 divorce, minus 0.01 age 25 to 40 minus 0.26 times age 45 to 64 minus 0.24 times ages 7 55, 55 plus 0.65 times ages of 75 above. Okay, divided by this one 1 plus exponential of A plus exponential of B from this one, from the Y3, from this goes here, from here goes here. So that is the full model for Y2. It also the same with the Y3, and Y1. Arasah? Good. So how to interpret in the matrix? So for the predicted probabilities of employment status by marital status for married men with the age of 25 to 44, for married, the probability for the employed is 86%, unemployed 4%, inactive 10%. Single 72%, unemployed 18%, inactive 9%, and divorce 72%, unemployed 19%, inactive 9%. So this is how you interpret using multinomial logistic regression. This is the methods. All right. Okay. Come. Okay. Turn off.
Pak, sorry.
Yep.
I checked to your Kaggle. There is a multinomial logistic regression code, but the title is multinomial logistic regression dash NPL score. Is it the same?
Okay, I'll put public here. Let me put it public. So maybe different.
Okay.
Okay, I just put this one public.
Okay, thank you.
Okay. So, all right, this is the Kaggle, multinomial logistic regression. Okay, so the objectives here is to identify the NPL score The NPL score is the non-performing loans towards all the stocks in the machinery industries. Yeah. So we have the ratio of debt to equity ratios, return on asset, sales growth, others and others. Yeah. The Y will be NPL. So in NPL there is 1, 2, 3, 4, and 5. 1 is all good. Sorry. The NPL. 1 is good. 2 is 30 days late on payment. 3 is 60 days late in payment. 4 is 90 days late from payment. 5 is 120 days late on payment. Delinquency rate. Delinquency is 120 days. Or 1 is the category of 1, you can do it also with the clustering result, whether it is highly effective. 1 is highly negative externalities, 2 is negative externalities, 3 is neutral, 4 is positive externalities, 5 is highly positive externalities. That can also do. Okay. And then as usual, we import NumPy SNP, import Pandas SPD. From scikit-learn, we import logistic regression. Yeah. From scikit-learn model selection, we import train and test split. So we model the data from the training. Yeah, we model the data from the training. From the training data, we model the data, and testing the data from the testing. So we split the data into 2, testing and training. And then from scikit-learn, we import pre-processing. And then from scikit-learn matrix, we import classification report. Nah, so this is for the reporting, yeah. Accuracy and also accuracy, cross-validation score, confusion matrix, yeah, confusion matrix. How many percent is the accuracy for the using the confusion matrix. And from matplotlib, we import matplotlib as MPL and matplotlib pyplot as PLT for the visualization. And then we import statsmodel.api as SM to get the statistical result. Statistical model. Stats model is statistical model.api as SM. So the data, we got it from the IDX data. And then understanding the table of from the data from IDX, the emitter name, the sales growth, return on asset, debt to equity ratios, debt to equity, and then return on asset, sales growth. Yeah, so this is the category. And then the Y there is 5 with the category of 0 is negative cluster, or bad cluster is 0, bad performance, a very bad performance. And then 1 is bad. Okay, so this one we use bad performance is 0, 1 is neutral, 2 is good, 3 is okay. Supposedly this is we okay. So since the cluster usually in the Kaggle, the result the cluster name is not accordingly with the A, B, C, and D. Yeah? So cluster A is, let's say A is very good, meaning A is 4, yeah, and then B is true 2, 1 is 3, 4 is 0, 5 is 3. Yeah, something like that. So explaining the condition of the cluster. And then let's load the data. So this is the data as usual, the industry, this is the company, the ratios, and the category of cluster. So you have the cluster category from the previous studies on the clustering result. So there is the result here already. So the data, you have the data already on the category. And then this is the data, the count number of data, the mean, standard deviation, minimum data, max. So let's display it, the industry, the company, the emittent codes, the ratio, and the categories. Okay. So let's do multinomial logistic regression with scikit-learn. Yeah, so we display the data, and then we see we drop the category, we drop number, we drop industry, we drop company, we drop emittent, we drop. So we have the data here. Okay, and then we have the category data. Yeah, the x and the y, the x hat and the y hat. Let's standardize the data. From scikit-learn, we import standard scalar as usual. Yeah. So when the data having outliers, so we can adjust using normalize the data using standard scalar. Yeah. So after we conduct standard scalar, we have the data here. So this is already normalized. We all normalize the data here. Okay, and then we display it again with the normalized data. Yeah, and then we conduct modeling using towards the training data. So we split the data into train X, meaning from the X variable we conduct training data and divide the data into training and testing. Yeah. Train X, test X, training and testing, training Y, testing Y equal to train underscore test underscore split X and Y test size 0.3. Meaning when test size 0.3, the training size will be 0.7. So testing size is 30% from the data, 70% is for the training. So this is the training size 70%, testing size 30%. So and then we conduct multinomial with the stats model library. So multinomial logistic model equal to statistical model. We just import the stat models.api equal to sm. So sm dot multinomial logit with y stats model add constant with the data, and then this is the model multinomial logit fit equal to multinomial logit model dot fit with the method of bfgs. Yeah. Print multinomial logit dot fit underscore fit dot summary. So this is the result of the multinomial logistic regression. So we see category 1, category 2, category 3, 4, and 5 as the reference. 5 is the reference. Category of 5 is the reference. So from here, we can develop the model. Okay. I forgot the abbreviation, yeah. In multinomial logistic regression. This one. So this one we get you can open the scikit-learn. Yeah, this is the scikit-learn website on the multinomial logistic regression. So BFGS. This one. Yeah. So it is there already stated in their standard model. Yeah. So this is the scikit-learn model logistic regression. The solver is using BFGS. So let's see what is BFGS abbreviation. Okay. Currently, multinomial is supported only by the BFGS, SAG, Saga, and Newton solver. Oh, this is kind of solvers. The type of solvers that being used by the multinomial options. Yeah. There is option is BFGS, SAG, Saga, and Newton CG. Yeah. This is the solver, the name of solver. BFGS solver. Yeah. The linear. Okay. Yeah. The option is Newton. Blah blah blah. The default solver is BFGS. What is the abbreviation? Wait a second. I'm also curious. The default is BFGS. Okay. BFGS. So this is the Python words only maybe, because they do not specify the abbreviation. Oh, this one. No. Software for large-scale bound constraint optimization. Okay, wait a second. Oh, back to the above again. Okay. This is the default solver for the multinomial logistic regression. So the abbreviation is not there in the scikit-learn, but this is the solver type in the multinomial logistic regression. Got it, Emma?
Okay, Pak. But if we put Newton dash CG or Saga, it will be the same, Pak, the result?
Do you want to try?
Well.
do you want to try with Saga? Okay, let's do it. What is the difference with Saga? I also wonder. Oh, error ya. BFGF then. BFGS. Yeah. The other one error, Emma. So BFGS is the one that works. Okay.
Okay. Thank you, Pak.
Okay, good. Any other questions? Before I assign the final exam assignment. Any other questions? Okay, no question. So,
No, sir.
yes, Wania.
Oh, no, sir. I don't have any.
Have the prediction on the testing data. We need to, we want to test the model into the testing data. Okay. Why prediction? Okay, logistic regression. Logistic regression is equal to logistic regression multi-class auto fit X and Y. Yeah. Why prediction is logistic regression dot predict dot testing of data X. So what is the Y prediction towards the using the testing data X? Y prediction is 1, 1, 1, 1, 2, 4, 1. This is the clustering data. This is the cluster. So towards the testing data. This is the result. Worry not about this one, because this is only the constanta. Yeah. The point is on the Y prediction. Yeah, Y prediction on the to put the model into the testing data. Okay. Okay, this is the model validation. This is the accuracy, print accuracy on the testing Y and Y prediction. So the data is there, whether it is 1 or 2 or 3 on the cluster on the testing Y. And the prediction is there. Now the new one is the Y prediction. So we need to identify the error rate, the accuracy. So the accuracy, if 1 is in the testing is 1 and the prediction is 2, then it is not accurate. So how many data is accurate? Accuracy is 78%. Yeah, with the error rate 22%. So this is the accuracy of the model. Yeah, the accuracy of the model. And then the confusion metric. So for the final exam, there is two options. Number one is using binary logistic regression. Number two, using multinomial logistic regression. If using binary logistic regression, that will be 1 or 0. Multinomial, you can do 1, 2, 3, 4, 5. Okay. And then you have your previous studies where the clustering we have 5 there. You can use that for if you use multinomial. And for binary, you can group one, let's say 5 and 4 is 1, 3, 2, 1 is 0. So you regroup again into 1 and 0. The objectives is to get the model of Y1 Y1 or for if binary only for Y1, because the Y0 will be minus Y1, yeah, isn't it? Or in the multi, the objective is to find the model of Y1, Y2 until Y5. And then you develop the matrix. If this is Y1, Y2, Y3, Y4, yeah, this is the testing data of Mr. A, Mr. B, Mr. C, Mr. D, or company A, B, and C. What is the probability for each of the Y? What is the probability of Y5, Y4, Y3, Y2, or Y1 and Y0? So far so good. You can also do it with the other industry, no worries. Yeah, you can do it with the other industries, identify it using the clustering data first, and then grouping the data into 1 and 0, and then develop the...
Sorry,
Yes.
sir. May I ask what is the process for the exam? Will it be released like on short notice, or will we have time to do it?
Come again, Vania?
What is the process for the exam, if I may know?
The process of the exam?
Like,
Yeah, you need to
because
develop...
on Moodle it says it.
You need to develop the deck and the journal. Yeah.
And when is it released and when is it due? Because on Moodle it says 22 October or something.
On Moodle 19 deadline. 19 October on Moodle. Yeah. But 19 October you will not be able to present it. So I am doing it. I open the I open the final exam now is for you to be able to present the deck first. Present the deck because I need you to I need you to have the present the deck first and then develop the journal. What I will mark is the journal. I will mark the journal, not the deck. But I need you to have what we call that. You present the deck first to me, and then
We present
Yeah.
on the 19th.
No. You present on the week 13, week 12. So this is week 10, yeah. Today is week 10. You present the deck on week 12. You have 2 weeks to present, and then week 14, week 13 will be holiday. Week 14 will be deadline for submission to Moodle. So the deck and journal you submit on week 14. So around 19th of October, yeah. So you have 2 weeks to develop the deck and then present it in week 12. But the exam will be onto the journal. Araso wania,
Yes, sir.
yeah. Okay.
Yes, sir. Thank you,
All
sir.
right, cool. So I will put the detail in the assignment, yeah, for the final exam. So you have 2 weeks to present and then 2 weeks to develop the journal. So you have time to develop your journal. Any more question? So which one do you prefer, binary or multinomial? Which one do you prefer? Which one is more easier, binary or multinomial?
None.
Okay, no worries. Alright, is no more question. Then we continue to the post test. Wait a second. Okay, record. Okay. So after we have this one.